All right, welcome back to another lesson. And today we're gonna kind of leave quadrilaterals just for a little bit, and we're gonna talk about polygons in general. And there's kind of a certain way that we can find area and perimeter of any kind of polygon, no matter what the how many sides there are. And we're going to first kind of describe what polygons are. So let's get started. We're going to be on pages 104 and 105 today. Okay, so first we're going to start on page 104, and we're just going to label these pages polygons. Okay, so polygons. So a polygon is a closed, multi-sided, and is segmented. What that means is this means that it has no openings, okay, that there's actually an inside and an outside. Multi-sided means that there's more than two sides. So the smallest polygon that you can have is a triangle with three sides. And segmented means that none of the sides have any curves, okay? So they're all straight segments on each side. There are four different labels that we can put on polygons. The first ones are either convex or concave. And you've heard of these before, probably talking about lenses or mirrors in a science class. And it's kind of the same type of thing with math and with these shapes. So a convex is something, well, let's start with concave. So concave is any sort of shape that has a cavity or a cavern to it, something that goes to the inside. Okay, I think by definition it says where you can put 2 points on the shape and draw a segment between them that is both on the inside and the outside. So for example, if I put a point here and a point here, and I draw the line, the end points are on the inside of the shape while the segment goes on the outside. And if you have a convex shape, that cannot happen. Whoop, I kind of messed that up. Okay, that should be a straight side right there. Segmented side, my bad. Okay, and here I cannot find any 2 points where I draw a line and it's both on the inside and the outside. Okay, so that's convex and concave. We will mainly deal with, we will only deal with convex polynomials or polygons, sorry. And then the other two, you have regular and irregular. Okay, and a regular polygon means that all sides are the same. Okay, so all, in this case, all 8 sides have the same measure, which means all the angles are the same measure. If you have an irregular polygon, some of the sides may be different. So maybe all 4 of those are the same, but these 2 are different. That is irregular. In fact, the 2 that I drew up here are irregular. So our main goal is we're going to deal with regular polygons because things become easier for us to start there. And then as we move into more advanced math, we'll look at irregular and concave. Okay, so there are some properties that you need to know for polygons. So We're going to do that on page 105. So polygon properties. Property number 1 is that exterior angles sum to 360 degrees. Okay, and that's no matter what shape or what polygon you have, that your exterior angles will sum to 180. And in fact, this works for irregular and regular polygons, okay? Not necessarily concave, okay? We're not dealing with those. So if I have some polygon, let's say that, the exterior angles are these angles right here. So we just kind of extend the line here. We did this with triangles, that angle and this angle and this angle. Okay, and if I add all of these up, okay, you will get 360 degrees. Now, with a regular polygon, those angles are congruent. With irregular, angles are not congruent. Okay, they're not the same. Okay, so exterior angles add up to 360. All right, property number 2. Interior angles sum to 180 in minus 2. Okay, and in this case, n is the number of sides. Okay, so why is this? Okay, so if I draw some polygon, okay, I have this polygon, it's irregular polygon. What I can do is I can break this polygon up into triangles. Okay. And I know that each triangle, the 3 angles on the inside add up to 180. Okay. And in this case, there are 1, 2, 3, 4 triangles. Well, I had 1, 2, 3, 4, 5, 6 sides. So if I take the 6 sides, okay, and subtract 2, I get 4. And 4 is the number of triangles. Okay. So n minus 2 number of triangles. Okay. And then you just take the number of triangles you can make and multiply it by 180. Okay. And then if you want each individual angle, you just divide by how many angles there are. And we can only do that with regular. So with regular polygons, angles are congruent. And with irregular, angles are not congruent. Okay, so that's a little bit tricky on finding that one. Okay. Okay, number 3. The perimeter of a polygon is the sum of all the sides. Okay, that's no different than any other shape we've had. The polygon, any polygon, you just add up how many sides. With regular polygons, okay, the sides are all the same. So if there's 8 sides and they're each 2 in length, you could take 8 times 2, okay, or you just add them all up. And number 4, our last one here, the area of a polygon is the sum of the areas of the inner or interior triangles. Okay, and there's a formula for this, which is A area equals N times B times H over 2. Okay, and let's look at that. Okay, N is still the number of sides. Okay, so if I have a polygon here, and we're going to deal with regular polygons. Forgive me for not drawing a perfect octagon here. Okay, but we know all the sides are the same. Okay, and what I'll do with this is I'm going to split it into triangles. And in fact, I'm going to have 8 triangles because that's how many sides I have. And that's where the number of sides come from. So I have 8 triangles. And if I can find the area of one of these triangles, I just have to multiply it by 8 to get that. So to find the area of a triangle, you take 1/2 the base. So this is B times the height. And all these are B. B, B. Okay. And then I multiply it by the height. Well, this height has a special name. Okay, it's perpendicular there. This height has a special name, and it is called the apothem. Okay, the height. In this case, we just label it H. Sometimes it's labeled A for apothem. Okay, so you're going to take 1/2, which is the divided by 2, your base times your height, and then multiply it by the number of sides that you have. Okay, so I'm just going to do a couple examples here on this page. I don't have a ton of room, but that's okay. We'll kind of squeeze 2 examples in here. So on this one here, we'll say find the sum and one interior angle of a regular hexagon. Now, if you don't know, a hexagon has 6 sides. Okay, so we can kind of draw this shape, 6-sided shape here. And it is regular, so we know all the sides are the same and all the angles are the same. Okay, so to find the interior angles, I can split this thing up into triangles. Okay, I have 1, 2, 3, 4 triangles. So you take 4 times 180. Okay, and 4 times 180 is so you got 360. So 180 and 180 is 360. 360 and 360 is 720. Okay. So if I add up all the interior angles, I get 720 degrees. If I want just one of them, remember there are 6 of those angles, I just divide this thing by 6 and I get, let's see, 6 goes into 7 once, 120. I get 120 degrees. So the sum is 720, but one of the angles is 120 degrees. Now that doesn't, it doesn't matter how big or how small the hexagon is. The sides could be 3 or the sides could be 100. All the angles will still be 120. Okay, let's look at an area one. Let's just use the hexagon too. Find the area. And I'll draw the picture. So we'll put it over here so there's room. Try to draw a decent hexagon this time. Okay. Now, sometimes they give you this length right here, and sometimes they give you this length right here. So we'll say that this bottom length here is 4. Okay. And let's say that this height right here might be, actually, there's a specific number it has to be. If I could find my calculator. Here it is. Okay, so that side would actually be we'll just go with 3.5. Okay, so I would find the area. So to do this here, I would find the area of this one triangle right here. So that's base, which is 4 times the height divided by 2. And I'm actually going to have 1, 2, 3, 4, 6 of those triangles. So we multiply by 6. So 4 times 3.5 is 14. Divided by 2 is 7. And then 7 times 6 is 42. So the area of this thing would be 42 units squared. Okay. I will put some practice on the Canvas site so you can get used to finding the area and interior and exterior angles before you take the quiz. As always, if you have any questions, feel free to reach out, and I'll see you in the next lesson.